to this video. So today we will solve one more LeetCode question which comes under medium. So the question is 347 top k frequent elements. Let's understand the question. Given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order. Okay, so we need to return the most frequent elements. So let's understand the examples. So in this example, the nums has 3 ones, 2 twos, and 1 3. Okay, so and k is equal to 2, so we need to return the two most frequent elements. So in this, 1 has been used 3 times, and 2 has been used 2 times, and 3 has been used 1 time. So this means 1 and 2 are the most frequent elements. Now need to understand the second example. So second example is simple. So 1 is the only single element and k is equal to 1, so the output will be 1. Now let's understand the constraint. So constraint is the length will be greater than equal to 1 and then less than 10 to the power 5. So why we are checking on the constraint? Because since you check this constraint, now you no need to do the null checking or anything, because the num's length will minimum be 1. So in this case, you don't have to check whether your array is length 0 or null or doesn't have any elements. So these things will be cut off, right? So it makes your program much simpler. So now the value of the num will be minus 10 to the power 4 to 10 to the power 4. Okay, now value of k is in the range of 1 to the number of the unique elements in the array. Okay, so so k value will always be like greater than or equal to 1, so we don't have to do any null checking. And it is saying that it is guaranteed that the answer is unique, so you don't have to check any other cases other than what it has been mentioned. Now as a follow-up, it has been given your algorithm time complexity must be better than O of n log n, where n is an array size. So that is the thing. So you cannot use any kind of shorting. I think you can use shorting, but it should be better than n log of n. Okay, so by seeing the frequent elements, you have a thought process. Like whenever these type of questions is asked during the interview, like the frequency or anything, you need to use the hash maps. So it will be very useful in these kind of questions. Have a tendency of using hash maps, or even in any question you don't know, just try putting hash map or hash sets. Most of the time it resolves some part of the question. So in these type of questions also you need to put the hash maps. So with these hash maps we can count the frequency, and we can come to know like 1 is 3 times, 2 is 2 times, and 3 is 1 times. So this frequency, so half of the question is solved. Like we come to know that like which is the most frequent. Now we need to think of something how we can return the top kth element which is frequent. So I'll give you a trick. So whenever a question is asked top k elements, top k greater elements, top k smaller elements, in these type of questions you need to use heap. It will be very useful. I think most of the question you can solve via the heap of these type of questions, like where it is asked for top k elements. So this is my array. Like I told, we will going to use the hash maps. So this will give us the frequency of the elements. Now in this hash map, what we will put? We'll put the key as the number, like 1, 2, and 3. In this case, the array elements, and the value is the frequency. So in this case, my 1 is used 3 times, 1, 2, and 3. My 2 is used 2 times, and my 3 is used 1 time. So my hash map is ready. Okay, now we come to the min heap. The property of the min heap is such that the minimum value will always be at the top. So this is its property, and it will give you every time. And whenever you use the max heap, the maximum element will be always at the top, and it will give you the max heap. Okay, now in this min heap, what we will put? We will not put the elements, we will put these values, these frequencies, because we need to give the most frequent element, right? So we need to heapify the thing with the most frequent element. Okay, So whenever you put the data into the min heap, it heapifies it if your minimum element is not at the top. Okay, now if we will consider only these values, okay, now in these values we will put 3. Okay, so I added 3. Now I added 2, so I'll add 2. Now this is 1. Now I added 1. So whenever your heap size goes beyond this k element, we will pop the element. And since it's a min heap, so your minimum value will always be at the top. So now my size becomes 3, so I'll pop the first element. So what remains? 2 and 3, right? And my k value is 2, and my this value array is also over. So my most frequent element is 2 and 3. This is the most frequency. This is the frequency actually. So corresponding this, my values are this 2 and this 1. So we can return 1 and 2. And since the answer says like in any order, we can return in any order, right? Now to understand the complexity, it should be better than n log of n, right? So this insertion is of 1, and the heapifying is actually log of n. So anytime you do log of n, it will take, since like in the binary search, in the binary tree, you do the heapify, so it takes half of the tree and heapify it, right? So its property is it will take log of n or even lesser than that. So it will be under our constraint, which is like it should be better than n log of n. Okay, hope you understand the question. Now we'll write code for this. Okay, now like I said, we need a hash map. So first we create a hash map, and what we will add, since we need to return these elements also, so we need kind of key value pair both, because if you will put only value in the heap, then you will not make out while sending the result. You cannot say like value belongs to which key, because we need to send the key as a result. So we need to store both. We'll create a hash map where we'll write we will create a hash map of key value as an integer. Right, and now we need a heap as well, right? So we will create a min heap. Okay, now in the heap we cannot simply put the integer, because if we put simply the integer, only the values part, then you will not be able to make out like what is the corresponding key, because at end of this program we need to send back the keys. So we need to put both the key and value pairs, right? So we can add map.entry object, okay, of type integer and integer. Right, this is our heap. Okay, now since heap, if you put the integer, it will heapify or sort it accordingly, and you will be able to get the min heap. But since you are adding here as a custom object, so you need to pass a comparator. Okay, so yeah, I'm just passing a function. So I need to tell them like how I need to sort it, right? So I need to sort it on the basis of value. So I cannot say sort it heapifying. So it will be on the basis of, it should be on the basis of value. Okay, so now my heap map is ready. Okay, now I'll create my map data. So I'll add int n, and I'll traverse the nulls. So I'll add the frequency. map dot put n, which will be my key. And if my map is, I am adding this element for the first time, so I'll add it 0 plus 1, or else whatever it is present in the map, I will retrieve it and I'll add plus 1 to that. Okay, so I'm doing get your default, and so my default is 0 if nothing is map is having null for this key, and I'll add it 1. Okay, now I'll traverse this map. So this map entries object, okay, now like I said, what we will do, heap dot add entry. Since now you have passed the comparator, heap will know how to heapify it. Now if we will check if heap dot size is greater than k. If it is greater than k, then we need to remove the data. We will do the poll. Okay, so now at any time this heap will always be equal to k. Now this is done. We need to create, since we need to return an array, we will create a result array. Res of size k. Okay, so what we can do, and for adding the elements, I can add int I equal to 0. Now we'll have a while loop where we'll check if my heap is empty. Till my heap is empty, what we will do, I'll add my data in my result object. So what we will do, heap dot poll dot get key, because we need to send only the key. Now my result object is perfect. Now again return it. Okay, so this is exactly what we have discussed. So we have written it. Now we'll try to run the test cases. So okay, I'm sorry, new is missed. Is there any other errors? No. So our test case is passed. Let's submit it. So it got submitted. So hope you understood this question. See you in the next video. Thank you.